My name is Luis Harold Asturias Méndez. I'm from the Lawrence Hall of Science, the Science Center of the University of California in Berkeley, where we work on addressing issues of equity in science and mathematics. I have been working for over 20 years on connecting language and math. I want to share some of what I have learned over that time with you. Please remember to download my handouts from the resource space on this website. Following this recorded presentation, I will be responding to your questions in the chat space for the live Q&A. Now, let's get started. Today, I'm hoping to give you a window into how language development and understanding mathematics concepts are both interconnected and mutually supported. How you cannot do one without the other. I'm going to start by describing who are those students that I'm talking about, who I'm focusing on. Then I'm going to talk about why, my whys, why I'm doing what I do, and why we should focus on these students. Then we'll go into thinking about what do they need, or how do we use some principles of design to create learning experiences for those students. Then we'll introduce you. I will introduce you very quickly to some routines that can be used in designing learning experiences for students, and we'll finally get to implications for your practice and a little bit of closing with some actions, some concrete actions that I will hope that you take. So let me start by talking about who are the students that I am talking about. And these are students at the margins. I'm talking about a heterogeneous group of learners that includes students learning in dual language contexts, students who are multilingual, and students who are bureaucratically labeled as English learners. But most important, we're talking about linguistically and culturally diverse students for whom language is the reason for getting minoritization, marginalized, and that's due to a systemic racism that we experience in education, but also for whom language, culture, and literacy are the greatest assets. So as we think about them, then we have to think about why are we focusing on these students? Why do we have to focus on them? And one of the reasons is because there is a problem that we're trying to address. And that is that some students, particular students who have not been served traditionally, they have not given the opportunity to access high quality, relevant, and cognitively demanding and grade level mathematics. In fact, too often they are dissuaded from pursuing higher math courses. And we are using the NCSM, the National Council of Supervisors of Mathematics, and TODOS joint position statements on social justice in mathematics to address these issues. And we know some things to be true. For example, the deficit thinking has plagued our educational systems for too long. And it is still a dominant view held today by some people in those systems. Secondly, we know that in order that we all use mathematics to make sense of the world in a quantitatively way. And making sense of mathematics in that way requires productive struggle, which also means that we have to design learning for students that tend to or produce, that helps them in that productive struggle. One of our most important roles then is to empower students, particularly students of color. And we know that racism and inequity are products of the design of our educational systems. These systems can be redesigned to support students' learning, agency, and identity. Our job is then to redesign the parts of the systems for which we are responsible and to advocate for improving other parts of those systems. And we start by shifting from planning lessons to designing powerful learning experiences for all students. That means that we need to embrace a theory of action, a theory that connects our actions to the outcomes that we desire. And hopefully those outcomes are our why, our students. If we want to produce students who experience academic success, who understand their own and others' cultures, and who communicate their way of thinking effectively, and develop a socio-political consciousness so that they can thrive in a world of constant change, then we need to take some actions. We need to develop our own capacity to create opportunities for students, for those students to experience and learn grade level, relevant, and meaningful mathematics. We need to build their sense of self-belief and the sense of belonging so that they can learn in a more coherent way. We need to also learn how to prioritize learning and teach the students the concept, the main concept, the most important concept at each grade level. And then we need to recognize and value the assets that the students are bringing with them to the learning environment, and then build from that and use those to create a learning experience that is coherent and relevant. So the question is, how do we do that? And I want to propose that we do that by emphasizing three aspects of their learning. The first one is that we need to develop in students a habit of reasoning about mathematics. So anything that we design, we have to create opportunities for them to develop that habit. The second one is that we need to help them learn to use language for academic purposes. Unlike we thought before about they need to learn academic language, beyond academic language, they need to learn how to use language for academic purposes. If you think about it, in the classroom, we don't use academic language every time. We use everyday language to talk about mathematical ideas. So they need to learn to use language for academic purposes. And the third thing is that we need to build a sense of belonging in a way that develops in them their agency, their ownership of their learning, and a strong mathematical identity. If we develop those capacities in ourselves, if we do this with these three things for students, then we will produce students that with the characteristics that we described earlier. So what we need to do then is to connect the grade level mathematics, the language, and their identity as three aspects of learning that are always present, even though one at a time may come to the foreground. So the identity work might be at the foreground, and sometimes it is the mathematics that comes to the foreground, and other times the language comes to the foreground. But all three are always part of the whole learning process of a powerful learning. And these three aspects of the learning become a backdrop for the designing of our lessons. So when we design lessons, then we need to think about a way of learning that start with what students know or do not know, what experience that they have had about the big ideas they're about to study in the next lesson or unit. And so that's called diagnostic teaching. And diagnostic teaching is focused on developing students' understanding by launching a lesson with a relevant tasks, a task that is a high cognitive demand task, or low floor, high ceiling. Then having students make sense of the mathematics with peers, that socially negotiating meaning and helping each other learn about the mathematics that they're seeing in that task. And then end with a discussion and a summary of the learning, the mathematics that they're learning. This design is split into two parts. The first 2/3 are divergent. That means that the purpose of the first 2/3 of a lesson of this design are intended to uncover all the ways of thinking that students bring to the table as they work on the mathematics class that we put in front of them, and makes it public, or make that thinking public, so that we can compare and contrast those ideas, and by doing so, helping students make sense of the mathematics and learn from it. And then the last third of the lesson is a convergent part, is the converging on grade level mathematics, understanding the grade level mathematics that we are after. So if we have this design in mind, then we need to add to it some principles of design that we can use to design the activities, the lessons that we want students to experience. So besides ensuring equity by connecting mathematics, language, and identity, I use the principles of design identified by the Understanding Language and the Stanford Center for Assessment, Learning, and Equity, SCALE. These are two initiatives at Stanford University that are intended, whose purpose is to support learning of linguistically and culturally diverse students. And they have identified 4 principles of design. So let me tell you about those. And that's about principles of design, about how to use language to support the learning of relevant mathematics. The first principle of design is that any learning experience we design for students, but particularly linguistically and culturally diverse students, must support their sense making, asking them to make connections, defining and redefining terms, and asking questions themselves, asking questions of the text, of themselves, of each other, so that in that way making sense of the mathematics that they're learning. The second principle is that we must optimize output, designing prompts that require students to produce language both orally and in writing. This will help students understand the 2 main functions that language play: receptive and productive. Receptive is comprehending the language, is receiving the message, the input, and comprehending it. And in language arts, we use a lot of reading comprehension to do that. So it's about thinking about how do we apply reading comprehension strategies to comprehend the language that we're using to talk about mathematics. The productive language function is about generating language. And by doing so, by having students produce and generate language, we're helping them learn the way that words and phrases combine to communicate our thinking and understanding math concepts. Language learning becomes more relevant when it is done in the context of understanding concepts rather than learning the parts of language in isolation. One way of thinking about it is language as action, action for academic purposes. The third principle is about cultivating conversations, strengthening the opportunities and supports for constructive mathematical conversations in pairs, in small groups, in whole class. If we believe that learning is socially negotiated and mediated, conversation becomes the vehicle for that negotiation, and language becomes the currency of learning. Students must learn and practice how to have those conversations by active listening to each other, asking questions of each other, building on each other's ideas, building viable arguments from evidence, and respectfully critiquing each other's arguments. All those are language-rich processes that we want students to be able to develop. And the last principle of design is maximizing meta-awareness. We need to strengthen the meta connections and distinctions between mathematical ideas, reasoning, and language. 2 main meta-awareness practices are essential: cognitive and linguistic. There is extensive research about the importance of metacognitive awareness, understanding how we learn from our unique and personal ways of thinking and learning. But equally as important is linguistic meta-awareness, understanding how thinking explicitly about language helps us learn, understanding language more than a mere communication tool as a thinking tool. And if you think about it, as adults, it's almost impossible to have an idea or think about ideas without language. So language supports ideas, ideas support the language. So 4 principles of design: anything we design must support sense making, optimize output, cultivate conversation, and maximize meta awareness. So that prompts the question of how do we implement these principles of design? And one of the two main ways that we have, 2 main tools we have, is to give students access to relevant grade level math concepts are pedagogical strategies and routines. And we can use a variety of strategies and routines in our lesson designs. And in the understanding language document that I show you a picture of, and I was describing, from which I took those 4 principles of design, how they have identified 8 mathematical language routines. So let me name them for you. And a language routine is a structured but adaptable way of amplifying the language that students are using. So it's about how do we support mathematical language development and concept development at the same time. So the first one is about stronger and clearer each time. And this is about using peer feedback and sequential pairs of students giving feedback to each other when they are creating an explanation, a justification, an argument to improve it in 2 ways. Make it stronger by providing more mathematical evidence, and make it clearer by paying attention to the precision and the clarity and the logic of the language that they're using. The second one is about collecting and displays, and we do a lot of that. For example, when we do math talks and we collect what students are saying, we make it public, we put it on a chart, on the board, and so that we can display it, what they're saying, so we can see it and evaluate it and compare it and contrast and do all the wonderful things we do. Critique, correct, and clarify, as its name implies, we use maybe pieces of work from the class themselves and use it to critique it, to compare it, to clarify, to correct, and do all that. Information gap is a strategy where students need to work with each other, collaborate with each other, because they don't all have everything that they need as an information. There is some gaps that they need to fill in by collaborating with each other. Co-craft questions and problems is asking them to come up with questions themselves and co-craft problems themselves, so that they can begin to learn how to think about how those are created. The 3 read strategy is about reading a word problem 3 times. It's intended to give students access to the complex text in word problems. And we'll talk a little bit more about that in a few minutes. And then compare and connect is, as the name implies, having pieces of work, students thinking and comparing and connecting, and making connections across, and also representing ideas in multiple ways and prompting connections across representations and using language to describe those connections. And the last one is about discussion support. And probably this is one that is the most, that you have probably used many strategies, is to support discussion, to support conversation. And 3 other things that are helpful. One is about thinking about the questions we ask. 3 types of questions: assessing, orienting, and advancing. I'm not going to be able to describe all of them or give you examples of all of them, but below each of these, there are some links to resources where you can learn more about this. But thinking about what questions we ask and how those questions support the discussions and the academic discussions is important. The second thing that I want to tell you about is the 3 Ps of turn and talk. And that is when we ask students to turn and talk, we ask them to, we give them a prompt that communicates a purpose. Why are they turning and talking? And then a product that they have to create as they do that turn and talk. And then some talk moves that come from Kathy O'Connor that are about prompts that we can use to promote the discourse in the classroom. So these are strategies. And so what I want to do is to highlight two of them, give you a little bit more detail, give you a beginning sense of what it looks like using the 3-read strategy. So the 3-read strategy, as its name implies, we read a word problem 3 times. And each time we're answering a different question. And if you take a word problem and you delete the question, you don't have a word problem yet. You have a problem stem or chose a situation. So I'm going to show you some pictures of a 3rd grade class working on a situation called Judy's Berries. And here's the situation that they're working on. Judy's Berries. Judy loves to eat berries for breakfast, lunch, and dinner. She sees that Clear Lake School is having a berry sale to raise money for a new playground. The students that decided to sell fruit baskets to raise the money. A strawberry basket sells for $3 per basket. A raspberry basket sells for $5 per basket. And Judy has $20 to spend. And as you can see, there's no question to be answered yet. So during the first read, the teacher reads the situation out loud. The students are listening, and then they talk about what the situation is about. So all they are answering is, what is the situation about? So nothing about mathematics or calculation or anything like that yet. Then they read it a second time. And the focus of the second read is to identify all the quantities, numbers, and units in the situation. The students in the class collaborate on making a list of all the quantities in the situation and talk about how those quantities are related, which is the key for understanding the mathematical structure of word problems, the quantities and the relationships. So all they are answering is, what are the quantities in the situation and how are they related? And then in the third read, the students are collaborating on coming up with all the mathematical questions they could ask of that situation. And the teacher then sends them to work on a particular question that they may have come up with. So that's a 3-read strategy, just to get an entry into the word problems, and then they get to work on it. But what's happening behind the scenes is applying reading comprehension, close reading as a strategy for comprehending text in language arts to mathematics. So in the first read, students are developing a text base. And what's most important there is language processing. They're processing the language, particularly thinking about propositions and phrases. In the second read, then we're asking students to develop a mental model. And in that mental model, we want them to identify the ingredients, the quantities, the units, and how they're related, because then they can assemble that, for example, with diagrams that show those relationships. And if they do that, then we can then query that mental model. So this and we can ask what was asked in the prompt or the problem if the question was there, and what other questions could we ask? And this is a way of getting students access, particularly English learners or multilingual students, ways to access word problems and thinking about the mathematics behind them. So let me turn to some implications of these ideas for your practice and do a little bit of closing with some concrete actions that we might take. One shift that we need to make, one implication is that we need to think about shifting from an old paradigm where we connected language and content and we thought of it as just vocabulary and grammar. Instead, we know that in a new paradigm, we understand the complexity of language and its function in reasoning and communicating about relevant grade level mathematics. We know that any math text is complex text for students. Therefore, we need to equip them with strategies and routines to tackle complex text, like the 3-read strategy or routine. And we need to support their understanding of using language for academic purposes to explain, justify, and argue from evidence. And we need to think about the fact that acquiring and developing language and acquiring disciplinary knowledge are not separate and distinct activities. They are mutually enriching processes. What that means is that we must amplify rather than simplify language. And simplified language means that we avoid talking about or using complex language. But amplifying means that we need to anticipate where students might need support in understanding the concepts or mathematical terms and providing multiple ways to access those concepts and terms. And in doing so, gain the understanding of those ideas. So before I close, I wanted to highlight a few actions that I think are important for us to think about taking to tackle that common problem of practice that we were talking about earlier. So when we need to engage families, so we need to explain to families how reading in the home language is very important, because then students become better readers overall. We need to provide families with tips of how to read together successfully at home. In other words, how to develop language at home. We need to provide them lists of multilingual books available online. And there are some websites here that might be helpful for the parents that you might have. Developing language is the first step, but also we need to add to those opportunities for students to engage in creating their own problems, justify their arguments, and explain concepts and ideas to others. And we need to use a variety of strategic groupings and routines that cultivate discussions, making sure that they are talking to each other, socially negotiating meaning. We need to use discussion activities and peer feedback as often as possible. And we need to give students a choice in what they will do and some autonomy in the way that they say what they're thinking. So as I remind you of these three aspects, the math, the language, the identity, and agency, I want to leave you with three summary statements about language that I want you to remember and try and use it as you think about designing learning for students, particularly those multilingual learners. The first one is that language and content are interconnected and mutually supported. The second one is that language, more than a communication tool, is a thinking tool. And the third one is that beyond learning academic language, students must learn to use language for academic purposes. If we do this, then we will create powerful learning and a coherent learning experience for all students. Before I go, I wanted to show you that there is one slide that has a lot of links to my favorite sources for resources about helping students and helping teachers connect language and learning mathematics. Thank you very much.
Hello, and thank you for coming to our session, to my session. And I'm hoping that you have heard some good ideas, new ideas about connecting language and mathematics. And here for another, I think, 10 or so minutes, trying to answer any of your questions. So if you have a question, want to make a comment, you can put it in the chat or put it in the questions and answers. And I think that I can address them as we go. I'm hoping that you find the ideas that I presented useful for your practice. We know that almost every teacher will have at one point in their career some English learners in their classrooms. And I'm assuming that you came to this one because you might have some students that are learning to use language in academic contexts in your classrooms, or have seen well, students like that in the districts that you work. And I'm wondering if you can identify some of it will be useful to me to know if you thought of any of those ideas as useful. So I'm and wondering what questions you have. I'll keep telling you some additional ideas that I have been using. This format, it's a little stilted for me because it doesn't allow for the interaction that I think is useful in learning new stuff, right? But I think that we have for too long kept content and language as separate events, as separate learnings, and we develop in students those habits of seeing them as discrete experiences. So starting in upper elementary and middle school, students go through their classes and they rarely see the connection between their language arts class and their mathematics class, and in fact, language arts class with any other subjects. They see them as two different content areas, different learning experiences that never connect. And we most recently, because we who have been thinking about these ideas and doing a lot of research on it, have come to the understanding that helping both teachers and students see the interconnectedness of language and content is essential, because language development or language develops best when we use mathematics as context for it. And the mathematical ideas will develop best when we help students think about how they're using language to communicate those mathematical ideas. Because when we think about our own ideas, the more complete our sentences are, the clearer our sentences are, the more complete and clear our thinking and our ideas are. So therefore, we should ask students to use better, more complete, more precise language. And at the same time, whenever we have a chance to highlight for them the different aspects of language, and one of those aspects that I always like to highlight for teachers and students is words that have multiple meanings. If you think about the word even, you can think about, if you take 15 seconds and think about all the possible sentences you can create where the word even has a different meaning, even you can do it. And there's many meanings of even, right? Like even, like windows are even leveled. If we're even if we do the same things, we're even, or we pay each other money that we owe, we're even. Even going to the store, there's many constructions in just the social language of language. But then we use it in mathematics as well. We use it to talk about even numbers. Even numbers, and even numbers is a concept, it's a mathematical idea. And even numbers, students need to understand what that concept is. But the other way that we use even in mathematics is to communicate a mathematical idea, but using the word even as a day-to-day language. That means that means that, for example, when we say an even amount of sugar and flour, we're communicating the idea of equal amounts, and mathematical idea of equality, equal amounts of flour and sugar. But when I say even amounts, I don't mean 2, 4, 6, 8, or 10. So it's not the mathematical idea of even numbers, but we're communicating a mathematical idea using the social language word even. So we need to highlight that for students. The other way that we use it to communicate a mathematical idea is when we say an even pound. An even pound means an exact pound. So we're communicating the idea of the exactness idea, of mathematical idea of exactness, but using the word even. When we say an even pound, we're communicating a mathematical idea using social language, the word even as a social language word. When we do that, and we do this all the time in the classroom, when we're speaking to students, when we're using everyday language to communicate in mathematics classrooms. So, but if we are able to communicate that for students and highlight those switches, when we switch from one register to the other, they will develop the ability to think carefully about when they're using the language to communicate a mathematical idea, and whether they're using the mathematical language or need to use the mathematical language or just the construction. So I have a question that says about how does linking learning and language differ when there are multiple languages used by students and when there is one primary language used by the students. So there are many classrooms. When I started teaching in Los Angeles, we have classrooms that had up to 20, 25 languages spoken in the classroom. And one important part is to have students learn to use the language that is primarily used in the classroom, but building from their primary language. So it's almost impossible to accommodate all of the languages, but we need to make every possible effort to support their development of the literacy in their primary language, because that's going to support the transition to the dominant language in the classroom. In most classrooms is English, and helping them see those connections. And if we are aware of the ways that different languages and the way that different cultures use language to communicate those ideas, then we're going to support them. Like many African languages that use different points of reference, for example. So I hope that you have more ideas to go and find out more about these connections between language and math, and that you create those opportunities for students. Thank you again for coming. I'm hoping that I have at least provided you with some thinking ways to connect language and math. Thank you.